Well, I just wanted to show you a little trick. I've got this hole punch thing. Well, it's for punching out things, and you're supposed to hit it with a hammer, really. But what I've been doing is making myself some rubber feet. I get this. This is rubber foam. It's actually sticky back on one side, and all I have to do is put my my stamp, push, and twist. And I've got a rubber foot. Yeah, well, let's do another one. Actually, the sticky backs come off. But right, 2, 3. I've made myself 3 rubber feet. Actually, let's make it an even 4. If I can get it to come out. My table's knackered, so it doesn't really matter about the table. Right, I've got 4 rubber feet inside this punch. Now I'll just push them out. Fiddly, oops, flying away. Right, okay, I've got 4 rubber feet now. 2 of them got stuck together. That's fine. They're actually 4 rubber. Now the reason I'm showing you this is I've already done this. I made 4 rubber feet, and they stick together with double-sided tape on 2 of them. And my circuit board, which I mounted on my battery bank, I don't know if you can see, but between the board and the foam rubber on the supercapacitors, I have my rubber feet. I superglued the bottom and the top to the circuit board and the bottom to the felt. It makes it easier if I want to remove the circuit board later on, and plus it's mounted, there's an air gap between. So my PCB is basically mounted on rubber feet. Yeah, an easy way of doing it. It's a lot less messy than. I actually did glue some of my boards to the edge of this plastic, right on the very edge of the board though, so it's easy to remove. But for some of these boards, they're not the right size, so using the rubber feet idea is great because it's insulation, and plus the boards aren't being stressed in any way, and well, I suppose it'd be great if you're going over a bumpy road. Anyway, so yeah, I had to do some work on my counter actually, because I found out that because the voltage was so low, because I put a resistor on there, 2K, to keep the voltage low on the board, so it only uses about 4.5 milliamps, which is really, really low. So when this counter's running, it actually only uses 4.5 milliamps. So now what the problem was, that when I first powered it up, my counters were going to like 50 in random numbers, so I stuck a reset capacitor in, so when it's powered up it automatically resets everything. Well, there was one in there before, but it was just on one of the chips output, and I realised I needed to add another one. So there's 2 resets there now. When it powers up, it automatically resets to 0, and then it can start the counting. And I made this years ago at college, and I can't think why I didn't put 2 capacitors in there. Very odd. Anyway, yes, that's strange. No, it might be because the voltage was very low that I needed an extra capacitor. I think that's the only explanation. Anyway, thanks for watching. Oh, I finally got it sorted. I calibrated the current. I got the amp meter calibrated. I put the resistor on, just the correct resistor, and I had to wind a bit of wire around the resistor, tune it to get it just right. Talk about fiddly. Well, these resistors that are on the current limited circuit, they're like 1 ohm. That's like 1/10 of an ohm. So they're very fiddly to get just right. Even the legs can make a difference. Just to prove that, the current on the power supply at the moment is actually just a bit over. It's about 110 milliamps, but bear in mind that the circuit at the other end uses probably 20 milliamps. So that's pretty good. Anyway, I don't think I can get it much more accurate. One of the problems is on current setting at the moment. So amps. One of the problems with the calibration is that on the back where I've got the resistor, I put a load of thermal compound around it. I've got a thermal cutout switch, and the resistors are actually in series with that switch. Problem is, there's a bit of a resistance on the contact switch itself, and if the contacts aren't perfectly connected, as the current goes up, the contact resistance increases on this cutout switch. That throws my readings out. So, well, I'll just have to live with the little discrepancy, but basically the lower the current is, the more accurate it is. So it tends to be much more accurate around 300 milliamps, so I think that's pretty good. It'll have to do. And I sorted my, I'll have to turn, there you go, you can see it, it's tripped 2 times. I've got it very dim, I can read it myself. When I've got light on, you can't see it, it's only using 4.5 milliamps is my counter. 4.5 milliamps, that's all it's using through that resistor. So, yeah. And it's working great. Anyway, as long as I can read the counter and it'll use less power, that's good. And the MPPT is working. I'm actually charging up really slowly at the moment because the general idea is that once it gets charged up, the MPPT will probably go into sleep mode. And at which point, that's when the boost converter will do the work and do the charging of the battery, basically pulse charging. But obviously in bright sunlight, the pulse charger would probably never get it activated, so it would all be done by the MPPT anyway by then. So yeah, I've got it much more logical now. I need to my elastic band's got all skewy. I'll have to sort that out. And with the magic of video, I've straightened my elastic band out. It's just a bit of security, just to keep everything clamped up so nothing falls over. Shouldn't do though, because the wires are holding it on the top of here, so yeah. Just gotta wait for a nice sunny day now to test the thing out properly. I'm just having to charge it manually just to test it. But it's working a lot better than it was, anyway. Oops, I nearly fell over the ironing board just then. So, right, thanks for watching. Well, I got myself a laminator. I stuck a label on it just so that I know where to put the PCB edge, because if you put it too far up, it seems to get stuck. Anyway, I did some tests. Still wet. I'm not actually going to be etching this board though, because I've already built this board, but let's get the magnifying glass on it. It's a bit wet still. I did the pattern side, you know, with the component side, and it came out 100%. Actually, get the light right. See if I can get it right. I think I've got it upside down. No, I haven't. It's right way up. I did this transfer using this laminator, and well, actually I'm very surprised at the results. Actually, not one little bit is missing. Just to prove that, hang on. And this is a piece of paper that it came off, and the piece of paper had some imperfections on because it was a Duff print anyway, but Yeah. Well, the outside borderline wasn't on the board, but that line down the right hand side is irrelevant. But I can't find one black speck left behind on the paper. Oh, wow, cool. Best results I've had so far. Anyway, in the daylight, upside down now. Yeah. Still wet. Yeah, it's come out great. So I thought, well, let's try this on a PCB. And in here, oh, get the lid off without spilling it. Oh. Just stuck it on the top on because it's got bits of glue on it. I did another circuit board, but I haven't etched it. I'm not going to etch this. This was just a test. I might actually etch it though, because I've made some improvements to it. Just missing the tap. But unfortunately, the pattern on this one, on the other side, there are some imperfections, but that's because, actually it's not bad really. I think it passes. Yeah, it does, it's good. Some bits of glue on, that's all. Yeah, it's good. And the circuit board part, the printed circuit, I went around it. Even that thin line down the left hand side, which is irrelevant, which I don't even want. Even that's perfect, so yeah, very surprised. I can't find, you know, when I had to patch up the other board where the edges were, bits were missing. I think that was at this end here somewhere. Well, even they're on there, so yeah. I thought, wow, cool. This laminator is brilliant. Much better than ironing. So, get it right way up. Yeah, the writing's much clearer. Wow. Yeah, very good. Yeah, I'm happy with that result. Not bad for 18 quid for that laminator. It's worth it anyway. It's better than trying to iron it. Did get stuck a few times because I put it in too near the edge. Oh, that's just some paper that's on the edge there. Nah, it's just one's rubbing off. Yep. I'll leave it soaking a bit more because there's still some gluey bits. But, brilliant, yeah. Thanks for watching.